Now in this task, we are going to start learning more about the tangent function. So let's recall the right triangle definition of tangent. If we're taking a tangent of A, it is equal to the length of the opposite over the length of the adjacent, opposite over adjacent. Now number 1 asks you to revise this definition to find the tangent of any angle of rotation drawn in standard position on the unit circle. Explain why your definition is reasonable. Now I went ahead and just duplicated this circle because as you can see, I have a unit circle on here because a unit circle is just a circle with radius 1. And let's look at this triangle and let's figure out how we could define tangent of A. Now, as a review, remember, sine of A, or of your theta, would be equal to opposite over hypotenuse, and the hypotenuse is our radius. So it would be y over r. Cosine is adjacent over hypotenuse, and the adjacent side is just x, so it would be x over r. And tangent, now, let's think about it. It's opposite. Opposite side is the height. It's how high up you go. It's the y value. It would be y over the adjacent side, which is x. So tangent of any angle is just going to be equal to y over x. So if you know this coordinate right here, tangent is just y over x. It's nice you don't even have to figure out the r or the radius if they don't give it to you. Now we have observed that on the unit circle, the value of sine and cosine can be represented with the length of a line segment. Indicate on the following diagram which segment's length represents the value of sine, which segment's length represents the value of cosine for the given angle theta. So this is angle theta. And we kind of just talked about this up here. But remember, r is 1 in a unit circle. So sine would just be sine of A, or sine of theta, would just be equal to opposite, which is y, over 1. So sine of theta is just equal to y. Cosine of theta is equal to x over r. And in this case, the radius is 1, so it would just be x. So sine is equal to the length BC, because that's how big y is. And cosine is equal to the length AC. There is also a line segment that can be defined on the unit circle so that its length represents the value of tangent. Consider the length DE in the unit circle below. Note that triangle ADE and ABC are right triangles. They're both right triangles, making them similar. Write a convincing argument explaining why the length of segment DE is equivalent to the value of tangent. Now, since these triangles are similar, and we know they're similar because these two angles are both right angles, they share this angle, so it has to be the same, and therefore their third angles have to be the same. And if the three angles of a triangle are the same, or are congruent with their corresponding angles, they are similar. And similar sides are proportional. That means we can set up the following proportion. I'm going to take DE and put it over AE. And then I've got to take the corresponding sides of the smaller triangle and make the same proportion. So DE corresponds with BC, AE corresponds with AC. Now how does that proportion help me? Well, I'm going to replace a few values that we know. First of all, AE is the radius of the circle, so I know it's equal to 1. So I'm going to substitute, I know AE is equal to 1, so I'll substitute that in for 1. Let's think about BC. What do I know BC is equal to? Well, BC was also equal to y. So I'm going to plug in y for BC. And AC was equal to x. So if we plug those in, we get that DE over 1 is equal to y over x. And that means that DE is equal to y over x, which is equal to tangent, because we just said tangent of the angle is equal to y over x. So DE is equal to tangent of theta. So if you take your original triangle right here and you just extend it out so that the bottom length here is the radius, and then just extend those two sides so it's a similar triangle, this length DE is the value of your tangent. Now this little proportion also leads to another property that I think is important. DE, or tangent, was equal to y over x. Well, I could have also replaced BC with sine and AC with cosine from right here. So I could have also written that DE over 1 is equal to sine of theta over cosine of theta. And since DE we just said was tangent, tangent of theta is equal to sine over cosine. Now that's an important property to know because we'll use it quite a bit. Tangent of an angle is always equal to sine of that angle divided by cosine of that angle. Now I want you to go on and try to answer the remaining questions on the task, and then we'll go through it together. Good luck!